In this video, I'll be giving an in-depth demonstration of the Capote SuperForth compiler. I'll discuss more benchmarks and we'll take a look at the source. In this benchmark is a linked list, and I want to demonstrate that Capote has all the syntax checking features and error reporting features of SuperForth. For example, if I try to compile this program, which will not compile because it has a syntax error in it, it'll report it. It's right over here. Here is a missing semicolon afterwards. Notice how it has a semicolon here. Alright, so I'll fix that. And after it's fixed, see, and run it again. Oh, and here's another error. Reading uninitialized memory, row 39. That is because pen tail hasn't been set, so yeah. SuperForth has a wide variety of memory safety features, and one of them ensures that every property of a record has to be initialized when it's instantiated. Now, the particular fix for this case was the defer init keyword, which pretty much just tells the compiler to not worry about it. Alright, finally, finished compilation successfully, and we can take a look at the source here. This source right here is very, very similar to what SuperForth's intermediate bytecode compiler would produce. For example, it's a direct one-to-one correlation on each line. Now you might notice there are a lot of labels being used for control flow. And one of the reasons why those labels are being used instead of actual branching is because it better interoperates with existing SuperForth intermediate language binaries, and because of GCC's assigned goto feature, like over here, we can in essence call anonymous functions or anonymous labels, since ultimately when all functions are compiled down in SuperForth, they are merely a bunch of instruction pointers. And now let's go take a look at the source code. The vast majority of Capote's source code is in the emit file. This file converts SuperForth instructions to C instructions. Now, it's pretty much a bunch of hard-coded conversions, but this is a prototype. So, and over here, one of the quirky things I did was, in order to compile a bunch of arithmetic opcodes, because the C code is syntactically similar, I was able to just make one general purpose case for all of them. Over here, some nasty enum arithmetic, but in essence what it does is uses the enum to select the right operator and the assignment value for each arithmetic operation. Another really big issue with development initially was testing. because it was pretty much impossible to test where an error went wrong. One of my strategies for doing that was directly comparing the emitted source, like the emitted source, you can sort of see it through the printfs and puts, directly to the virtual machine source code. And the majority of the bugs I found were misimplementations of the virtual machine source code. And what I mean by that is, like, say, take this function, for example, load alloc. This loads an element from an array and puts it into the stack. Over here, the array register is A, 0, index register is B, destination register is C. However, initially, I was under the mistaken impression that the array register was 0, the index register was 2, and the destination register was 1. This is true for both load alloc I and load alloc I bound, which are variants of load alloc, except that you can have a hard-coded index, and load alloc I bound is a hard-coded index and bounds checking. This one over here, load alloc I, is mostly used for getting and setting properties. And yeah, that's one example of a bug I fixed. Another challenge was just prototyping in general. This code right here is 542 lines long. If I had written a compiler that targeted assembly directly, it would have taken me months or weeks to do. It's not possible to do it. It's not possible to do it in a weekend. However, because I targeted C as a transpilation target, it's much easier to understand, and I can roll out a prototype within the weekend, within the time constraints of this hackathon. In addition, there's a high degree of portability and a lot of performance at almost no cost. Yeah. Another